All right, so let's work on some examples on domain, range, and in behavior. We're going to write our answers in inequality and interval form. Really, you only need one or the other. I'm also going to write the answers in set builder, even though we didn't talk about the notes. I did want you at least to see set builder. All right, domain. Let's start with domain. Domain is your x values. So let's start with inequality notation. So domain uses left and right. So here's the rightmost arrow, but you can see it is continuously going right. And here's the leftmost arrow, and see how it's also going continuously to the left. So it's going left infinitely and right infinitely. So the domain is all x's greater than negative infinity or less than positive infinity. And of course, we don't have the or equal to symbol because you can't equal infinity. So that means in interval notation, we're going to use parentheses around negative infinity and positive infinity. And then finally, here in blue, this is set builder notation. And basically, it's saying the domain is the x's such that x is all real numbers. So that's what this symbol right here is. This is the symbol for all real numbers, which you should be familiar with a little bit from Algebra 1. Set builder is not required, but I do want you to see it in case it's used. Range is our y values. So range is the lowest point to the highest. So in this problem, the lowest point is right down here at the vertex. So our lowest y value is at 0. And we're going to use the or equal to symbol because there's no open dot. And really there's no dot at all. But a lot of times they won't write a dot. But if it's a solid line or a solid curve, that's the same thing as a solid dot. And then this graph is going up infinitely. In fact, it's going up infinitely on the left-hand right side. So that means it's going up forever. So the range is everything, every y value greater than or equal to 0 and less than infinity. All right, in interval notation, we'll do that in red. We're going to put a bracket around 0 because of the or equal to symbol, and a parenthesis around the infinity symbol. And then finally, set builder, the range is all y values such that y is greater than or equal to 0 or less than infinity. And really, I wrote infinity wrong, but really all we need is this here. Because if y is greater than or equal to 0, that implies that y goes all the way to infinity. So here's 3 different ways to write domain and range. And then in behavior. So let's first do our right end behavior. So and you'll see our right arrow here is our right arrow or right end. Since it is going right infinitely, we've already established that, as x approaches infinity, well, what is y doing? Or what is f of x doing? Is y getting bigger or smaller as we go to the right? Well, as we go to the right, we're also going up. So that means as x is getting bigger or closer to infinity, so is y. And then let's do the left end. This one has a left arrow, and that left arrow is moving left infinitely, so it is approaching negative infinity. And as we move to the left toward negative infinity, what is the y value doing? As we move left, we are also still going up. So there's our 2 in behaviors for this example. All right, and example 2. The domain is our x's, so I'm going to put x. And I see my leftmost point is right here, and that x coordinate is at -4. And I see the rightmost coordinate is right here at +6. Since it's a closed dot at 6, we have the or equal to symbol. It's an open dot at 4, so sometimes it's a good idea to kind of write the dots over just to remind yourself when to use an or equal to symbol and when not to. And if we wrote this in interval notation, it would be parenthesis around -4 because we don't include -4, bracket around 6. And then finally, set builder would be all x's such that x is greater than -4 and less than or equal to 6. Typically, set builder looks a whole lot like an inequality. So if you understand inequality, you shouldn't have too big of an issue with set builder. All right, and the range. The range we use our y's. Is for how far up and down the graph goes. So this one we got to be careful on because the lowest point of this graph, it has several lowest points, and they all reside right here on this horizontal line. But this is the low point of the graph, and the y value there is at -2. Y goes in the middle. We're going to use the or equal to symbol, and you may be thinking, well, we have an open dot there at -2, which is true, but also we have a solid line, which implies a solid dot is here at all the other coordinates. All right, and then the uppermost point, again, this is where we have to be careful. The uppermost point is right here. So even though there wasn't a point drawn here, that is still the highest point of that function. Just because this dot right here is the literal highest point you see, it is not what we're going to use for our range. So the highest y coordinate for this problem is 8. So it's going to be y is less than or equal to 8 in this problem. So there's our range in interval notation. It's going to be a bracket around -2 and a bracket around +8. And last but not least, set builder. The range is all y values such that y is greater than or equal to -2 and less than or equal to +8. And finally, in behavior. So we've got an issue with the way in behavior is set up on this last problem because, again, this represents the right end, but it's saying as x approaches positive infinity. And if we look at the right end, x does not get to positive infinity. So instead, we could say as x, let's do it two different ways. We could say d and e, because x does not approach positive infinity. But we could also say as x approaches 6, because that's the rightmost x coordinate in this problem. What is y approaching when x gets to 6? And it's also 6. So that rightmost point is 6, 6. And then same thing for the left-hand behavior. We don't really have a left end. We just have a left dot. We have a left end. We just don't, it's not approaching negative infinity. So this part, I'm going to put D and E for does not exist. But then more accurately, I'm going to write as x approaches that leftmost x coordinate, which looks to be -4, y is approaching, looks like -2. And there's our answer.